Question 3a. The points A is equal to 2, 1, B is equal to 6, 3, C is equal to 5, 5, and D is equal to 1, 3 are the vertices of the rectangle ABCD as shown. In part I, we're asked to show that the length of the line AD is equal to the square root of 5 units. There's a formula on page 18 of our formula book which allows us to calculate the length of a line segment. It says that given 2 points, P is equal to x1, y1, and Q is equal to x2, y2, the length of the line segment PQ is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. We want to find the length of the line segment from A to D. So these are the 2 points of interest. A is equal to 2, 1, and D is equal to 1, 3. To use our formula, we should label the first point as x1, y1, and the second point as x2, y2. From here, it's a matter of subbing into the formula and doing some calculator work. So we found that the length of the line AD is square root of 5 units. And this is precisely what we needed to show. Part II. Find, in square units, the area of the rectangle ABCD. Well, to find the area of a rectangle, we multiply the length times the width. Looking at our rectangle, I'm going to label the side AD as the width and the side AB as the length. In the previous part of the question, we found that the length of the line AD is the square root of 5. So we already know the width. However, we don't know the length. To find this, we'll need to calculate the length of the line segment AB. Just like the previous part of the question, we can find this by using the length of a line segment formula. Here, we want the length of the line from A to B. So the 2 points of interest are A is equal to 2, 1, and B is equal to 6, 3. To use our formula, we're going to label the first point x1, y1, and the second point x2, y2. From here, we'll sub in the values into our formula and do some calculator work. So we found that the length of the line segment from A to B is the square root of 20. In other words, the length of a rectangle is square root of 20. Now that we know the length and the width, to find the area of the rectangle, all we have to do is multiply these two numbers together. So our final answer here is that the area of the rectangle is 10 square units. Part B. Find the equation of the line BC. Give your answer in the form ax plus by plus c is equal to 0, where a, b, and c are elements of the integers. We are asked to find the equation of a line. On page 18 of the formula book, there's a result which will help us. It says that the equation of the line which passes through the point x1, y1 and has slope m is y minus y1 is equal to m times x minus x1. To use this formula, we need to know two things: a point on the line and the slope of the line. We want the equation of the line BC. In other words, the line that passes through the points B and C. So we actually know 2 points on our line. B is equal to 6, 3, and C is equal to 5, 5. Either of these will do when it comes to the point in our equation of a line formula. The other thing we need is the slope, and unfortunately we don't know this. However, we can calculate it. There's another useful formula on page 18 of our formula book which will allow us to find the slope of a line. It says that the slope m of the line passing through the points x1, y1 and x2, y2 is m is equal to y2 minus y1 over x2 minus x1. We have already identified 2 points on our line, B and C. To use our slope formula, we should label the first point with x1, y1, and label the second point with x2, y2. From here, we can sub into our slope formula. So we found that our slope, m, is minus 2. Now that we have a point and the slope, we're ready to use the equation of a line formula. Here, I'll use B as my point. So x1 is 6 and y1 is 3. The slope m is the minus 2 we just found. So let's sub these values in. From here, I can do some simplification by multiplying out the brackets on the right hand side. Minus 2 times x is minus 2x. and minus 2 times minus 6 is plus 12. We are asked to present our answer in the form ax plus by plus c is equal to 0. In other words, we'll want all our terms to be on the left-hand side of the equation and a 0 on the right. So here, I'll need to remove the minus 2x and the plus 12 from the right-hand side of the equation. Let's start with the minus 2x. Because of the minus sign, this represents subtraction. The inverse of subtraction is addition, so to remove a minus 2x, I should add 2x to both sides of my equation. Now, let's remove the 12 from the right-hand side. This represents addition, and the inverse of addition is subtraction. So to remove a plus 12, I should subtract 12 from both sides. From here, we can do some simplification. Minus 3 minus 12 is minus 15. We were asked to give our answer in the form ax plus by plus c is equal to 0. Here, the x term came first, the y term second, and the number term third. So to finish everything off, we should reorder things into this format. Our final answer for the equation of the line BC is 2x plus y minus 15 is equal to 0. Part C. Use trigonometry to find the measure of the angle ABD. Give your answer correct to the nearest degree. To find the angle ABD, it will be helpful to think about the triangle ABD. To visualize this, we should draw in the line joining D to B. The angle we're after is ABD. I'm going to label this with theta. In the previous parts of this question, we found out some useful information about this triangle ABD. We saw that the length of AD was the square root of 5, and the length of AB was the square root of 20. So, how can we use this to find the angle theta? Well, our triangle ADB is a right-angled triangle. And when we want to find an unknown angle in a right-angled triangle, we can use SOHCAHTOA. This result says that the sine of theta is equal to the opposite over the hypotenuse, the cosine of theta is equal to the adjacent over the hypotenuse, and tan of theta is equal to the opposite over the adjacent. In a right-angled triangle, the hypotenuse refers to the side opposite the right angle. In our triangle, this is the side BD, and we don't know the length of this side. the opposite is the side opposite our angle theta. In our triangle, this is the side AD. And we know that this has a length of root 5. The adjacent is the side which touches our angle theta, which is not the hypotenuse. In our triangle, this is the side AB. And we know that this has a length of root 20. We know the opposite and the adjacent. So we should look through sine, cos and tan and see which one uses both of these. Here we see that tan of theta is equal to the opposite over the adjacent. In our triangle, we have an opposite of root 5 and an adjacent of root 20. So let's sub these in. Our goal here is to find the value of the angle theta. To do this, we'll need to remove the tan in front of it. Whenever we want to remove something from an equation, we need to perform the inverse operation to both sides. There's a function called tan inverse, which is defined to be the inverse of tan. So here, we should take tan inverse of both sides. From here, it's a matter of doing some calculator work and some rounding. Our final answer is that the angle ABD is equal to 27 degrees.